Right then. Why do they stack easily, those saturated?
They stack easily because the forces line up.
The forces line up?
Fatty acids, they line up
They line
perfectly.
up.
London forces.
London forces, more interactions?
More interactions?
Of course,
Yeah,
of course.
perfectly.
And then that's why unsaturated fats don't.
Unsaturated fats don't, because they're banned.
Yeah,
They
they're
don't,
banned.
they don't have as many.
Yeah, they hate
opportunities.
each other. Yeah, they're selfish little
They
brats.
like each other.
Yeah. Alright, let's go on to the phospholipids.
Phospholipids.
What are they?
They're lipids, but instead of glycerols, they got fat. They got the phosphate groups.
Phosphate groups.
Phosphate
Let's
group.
go. How many fatty acid chains do they got?
How many fatty acid
Among
chains?
us.
How many? Two? They got two. Yes, sir. And the steroids, what are they?
They're kind of like the carbohydrates because they don't got oxygen.
They got no oxygen.
They don't got oxygen. They got 3, 6. They got hexagon, pentagon.
Pentagon right there, boys. And what is their function, even though we don't know this yet? They got
They're hormones and stuff.
yeah, and they use to like stiffen or lighten the cell membrane. Easy, of course.
Oh yeah, that's like cholesterol.
Yeah. Hey, next up, what are the sex hormones?
Estrogen and what is it, Wyatt?
Come on.
What's the sex hormone?
Testosterone?
There you go.
And
Let's go.
I don't even know. I know that from puberty class, not from. I know that from
Yeah,
sex
let's
ed, not
go,
even
let's
from
go.
Alright, let's go on
biology.
to the protein.
Protein.
A great
Protein.
episode.
What are the functions of enzymes?
Enzymes?
Yeah.
They speed up
They
reactions.
speed up reactions. How do they do that? How do they do that?
They lock and key the proteins or the whatever the substrate is. It goes takes a little gander into the lock,
Yeah.
and then it splits them
It
apart.
splits them apart. And why does it
Or
do that
puts
more
them together.
easily? Because it lowers the activation energy.
Lowers the activation energy.
Yeah, there you go.
Because they don't use much energy.
Of course they don't.
Because there's already a little mold there.
Yeah, the mold
For
is
them to get
sticking
right
them right
into.
together,
Mhm.
right there. What are the structural proteins?
Structural protein?
What are their
Oh.
functions?
Structure.
Structure, yes. Yeah. Use
What
the
does it
building
say?
blocks to make many of the body's tissues.
Oh, tissues.
Yeah. Storage proteins. What are their functions?
Their functions are store energy.
Specifically, amino acids.
Well, yeah, since they're made of. Duh.
Yeah. Right. Transport proteins. What do they do?
They help transport stuff across maybe like the cell membrane.
Yeah.
I don't know.
Of course they do. Of course they do. Carry substances from one area of the body to another, such as hemoglobin.
Goes all throughout the body.
All throughout, yeah. Hormonal proteins. What are they?
They're proteins that are hormones.
Yeah. What do they do?
Cell identification.
Cell identification.
I don't think. Is that it?
No, that's
No.
receptors.
What are hormones? What are
They transmit info from one area of the body to another.
Isn't that what the transport proteins do?
They transmit information, not substance.
Not stuff. Okay.
Yeah, there you go. And receptor proteins, they receive those chemicals.
They receive the hormones.
There you go. And bind, which is the.
Like insulin.
There you go, like insulin.
Insulin is the hormone and the receptors receive. Okay. I see.
Contractile and motor proteins. What do they do?
Oh, they help the muscles do this. They contract.
They contract? Let's go.
I don't know how. Does it say how?
No, they don't. And defensive proteins, they just fight disease.
They fight disease like white blood cells have. Like lysosomes.
Exactly. Why is structure important in a protein?
Structure important? You already asked me.
Why is it?
Because the structure decides structure is everything.
Structure is.
It keeps things unique. It keeps things with their functions. Lock and key enzymes wouldn't work without it.
Of course.
Like the transport ones wouldn't be able to do what they do without it. They wouldn't be able to bind to the receptors without it. The receptors wouldn't be able to take their hormones without it.
Exactly.
Transports wouldn't be able to transport without their shape. It's
Yeah.
for everything.
Alright, let's move on to the primary protein structure, the
Primary?
PPS.
PPS?
Yeah.
Oh, it's ordered the amino acids in the chain. In case you're wondering, they're arranged NH2 to COOH.
Yeah, they are. Good job.
It goes N to Ku.
let's go. Let's go. And what are those? How many amino acids are proteins made out of?
20.
20? Yeah,
20.
easy. Can you name them?
No.
No.
Can you?
No. R groups, they vary in structure, size, charge, and attraction to water. Why is that important?
What?
Why are R groups important?
They keep them varying. They make one R group different. They make one amino acid different from another so that they can form a different function.
And why?
And so they can like bind together in different ways in structure.
Yes, they vary in structure. Their size, electric charge, and attraction to water. Yes, sir. And the amino acid change. What are they joined by?
Peptide bonds.
Peptide bonds. Let's go. Let's go. True or false? Can peptide bonds be double covalent bonds or just single covalent bonds?
Peptide bonds?
Yeah.
Single.
Single only. Yes,
Only.
sir. I notice that each amino acid has a directionality. So what does that mean? Oh,
Already said
just
that.
like that. There you go.
It means they can only be put together one way.
Yes, sir. And what are these secondary structures? What are
Secondary structures. Oh, those are little repeating, like the alpha helix,
they?
or the beta pleated sheet,
Let's go.
or I like the beta barrel.
The beta barrel.
I like the beta barrel.
No, that's a protein.
Yeah, but I like the
Hey,
beta.
like the beta barrel? Let's go. What is this stinking alpha helix? I think you just said it.
Counterclockwise.
Sir. No, clockwise. Hands down.
Counterclockwise.
Clockwise downwards.
My alpha helixes are just more alpha than yours, I
Yours
guess.
alpha? Dang. Okay. What are these beta pleated sheets?
I don't know. I ain't beta.
Hey, you ain't
It's
no
like
beta?
it's like the wave structure and like pleated, like
Yes, sir.
a heater.
Yes, sir. True or false? Are they held by covalent bonds?
Are they held by covalent bonds? Technically. I mean, they're held together by like hydrogen bonds, aren't they?
Yeah.
Which is a form of covalent bond.
No, that's it. That's
Hydrogen bond is a covalent. No, it isn't.
Hydrogen's in the intermolecular.
Yeah, hydrogen bond is a different thing.
Hey, let's go.
It's between covalent bonds.
Yeah, in between. There you go.
What,
Hey, what is this tertiary structure?
tertiary structure?
Yeah.
That's the random folding.
Yeah, but
it's like precise, but it's
precise.
not predictable.
There you go. There you go. And what do these? What five bonds hold them together?
Disulfide.
Disulfide.
Hydrophilic and hydrophobic interactions.
Hydrophobic.
Don't say it. Hydrogen.
Hydrogen.
Hydrogen. And the one that's like other covalent bonds. It's like in parentheses. And then before that it says the actual thing. But charge interaction.
There you go. Charge interaction. Let's get it. What are charge interactions?
It's like when positive and negative attract. Like you have like
Oh, I see.
polar molecules.
Isn't
that,
that
like,
just
delta
hydrogen bonds,
positive.
hydrophilic and
No.
hydrophobic?
No,
and
hydrogen
sulfide
bonds are
They're like
hydrogen.
all charged. Like, aren't they all based on charge interaction?
But that's why it's like just a general charge. I feel like they could just say charge interactions and it would include all of those things.
Exactly.
Who knows?
Who knows? Like, these interactions fold the protein into its specific shape that is responsible for its function.
Makes sense.
What happens when that shape is lost?
Denatures. Doesn't
Denatures.
work. The shape is so important in biology. What's up?
We're studying. Yeah.
Okay, I'm gonna stop the video now. I don't want to be on camera anymore.
Lock and key. You know
What's
what
up?
they are?
I know lock and key.
Yeah.
Enzyme. Fill up. Substrate C. Bye
Hey.
gamers.
See kids?